Aerogel is a synthetic porous ultralight material derived from a gel in which the liquid component for the gel has been replaced with a gas without significant collapse of the gel structure. The result is a solid with extremely low density and extremely low thermal and conductivity. Nicknames include frozen smoke, solid smoke. Aerogel is the lightest and least dense solid material on Earth. Aerogel is so light, the mass of aerogel is slightly greater than the same volume of air. Aerogel has 99.8% air, that is why it is also called frozen air. Some aerogels are so light that if the air were removed from them, the density of what would be left would be less than that of air. How was the invention of such a light object? How is aerogel made and what are the uses of aerogel? Jelly is more or less known to everyone. Jelly is basically a combination of solid and liquid. Jelly is mostly liquid and this liquid is joined to a 3D solid structure. The solid structure of jelly contains numerous nano-sized pores. The solid structure essentially gives the jelly its rigidity, much like a skeleton gives the human body its rigidity. In 1931, Professor Samuel Kistler and his colleagues made a bet. The bet was, can you extract the liquid part of the jelly without damaging the solid structure of the jelly? Extracting the liquid inside the jelly while leaving the solid structure of the jelly intact, jelly will evaporate and solid structure will remain. But the problem in this case is that when you remove the liquid inside the solid structure will shrink. Liquid molecules are ejected, causing the solid structure to fold into itself and survive. Professor Samuel Kistler found a solution to this problem. We realized that replacing one type of liquid with another type of liquid would not cause any damage to solid structure. He took silica gel as a jelly and placed it in alcohol for a long time, causing the liquid it is in the silica gel to be replaced by alcohol. He then placed the silica gel in a high pressure vessel called an autoclave and filled the vessel with liquid carbon dioxide. Then high pressure and high temperature are applied until the carbon dioxide supercritical stage is obtained. In supercritical condition, carbon dioxide behave like semi-liquid and semi-gas. As a result, in this condition, the liquid in the gap between the solid structure of silica gel can be easily extracted without any damage to the solid structure. This is basically how aerogel is made. Professor Samuel Kistler published this discovery in 1931, which is very important material today. Aerogel, bluish transport material. Aerogel appears pink in ultraviolet light and completely transparent in infrared light. Now takes about the use of aerogel. Aerogel work as a very good thermal insulator. If cold or hot air molecule enter through the narrow sized hole in the aerogel, the energy of the air molecules decrease. So very small amount of air molecules can reach the other end. It is called Knudsen effect.